Hello, in this video I will show how you can use the Fracture Surface Analysis Toolbox in Matlab, short FSAT, to analyze the roughness of two fracture surfaces which form together a fracture. I strongly recommend to take a look at the other videos that show how to work with FSAT and how you can provide the metadata, how your raw data should look like, and what kind of results you are getting. Here we only highlight the changes now compared to a single fracture surface. And the first step, as usual, is to generate the metadata. For this, I went to the generate metadata.m script, which is provided by FSAT. It includes examples and explanations on how to provide metadata for FSAT for all possible scenarios. And I just copy and pasted the section that is interesting for two fracture sites into an extra file. I called it again metadata fracture. It's all structured in the same way as before. We have to provide a name of where we want to store this metadata, and then we go through the different parts. Remember, we have different cases in FSAT, which we separate the different kind of scenarios or geometries we want to analyze. Having two fracture sites is the last case. It's case D. We want to have figures printed out, and we decided to go for a PNG file format. Again, it's everything similar, like you already know it from two height profiles combining a fracture. So you provide top and bottom source files. You have a common results file, delimiter units, cutoff angles, and so on. Important here is you have to precise rotation angles for top and bottom, because usually you scan this fracture surface separately, so both might be rotated in a different angle. So we can provide those ones, or other parameters apply similarly to both surfaces. You already know the angle step of anisotropy for the anisotropic analysis, and for the surface roughness coefficient, or the true 3D roughness measure. And then you can provide, again, similar to the two height profiles, which be a cut through the fracture. You can apply here an aperture. So both fracture surfaces will be lowered to each other until this aperture is achieved as a mean mechanical aperture. So anything else then you have to do is to run this script and pass this file, which then is generated. As you can see here, I've already done that. Once the file is generated, this path you provide to the other script of the FSAT master. So the analyze sample.m up here, and then you run the analysis. I've done that before because it takes a substantial amount of time to analyze two fracture surfaces in high resolution, as it's provided here in the example cases for FSAT. Now I want to take a look at the results. So we have the fractures 3D folder, which then separate again in bottom and top, similar as you know it for the fracture 2D, where you will find all the analysis of the two separate profiles. Then you will achieve again aperture, histogram, and distribution. In 2D, this looks of course a bit different. So you have the statistics you see again. You have a lot of contact areas, which is normal, and then you get some kind of distribution here. And you can take a look at the aperture distribution in 2D, which will show you, for example, there's large areas of contact area, and maybe some macropores that might be grains that have been broken up during splitting, or other areas. And of course, you again get a mat file with all the information. So you get the results regarding the aperture, so the mean aperture, minimum, maximum, standard deviation, and contact area. You get the X and Y coordinates, and you get the actual aperture opening. So now you can, for example, use those ones for flow modeling, or any other kind of analysis you would like to do, your own plotting, and so on. You can also import the workspace Again, every output is also provided as a CSV file, so you can open it with any kind of editor or tabular analysis software. If we look at the results now, we see here a lot of data. So this is again the huge number of surface roughness parameters that we are looking at. And now, because it's a 2D surface, we have for the top and for the bottom each the values in both directions, so X and Y direction, and we can change see if they are anisotropic or not in those two directions. Remember that in the separate folders you're getting results which show also visualization of the different profiles depending on the angularity or the angle step size you provided in the metadata file. You're also getting provided the difference between the two surfaces in dimension 1, dimension 2, and the mean value of both. This for these mean height derivation that is less interesting, but we can look, for example, here at the zero crossing values, so you can see if they are different or not. You see here, for example, the minimum values agree very well. And then you can decide, okay, is there a significant difference or not? Do I want to use mean value or not? You can decide all that's based on the parameters, right? For example, here for the JRC, you see they are very similar, 11.8, 11.5 in the anisotropic, which is very small. And if you just look on top and bottom surface, you will see that at 11.88 and 11.81 is very similar. So here you could say that for the TRC, for example, the anisotropy is low and the both fracture halves, the top and bottom, are also very similar. All right, can be examples where those ones differ very strongly. This will then also, of course, result in a different aperture distribution, all this kind of analysis now you can do using this kind of data. And this is already it, because there is not much new coming just for two fractures besides the additional rows in this table. And I hope you found this video helpful. You're enjoying using FSAT as a contribution to your work. And if there are any more questions, take a look at the FSAT manual and our respective publication, which are both linked in the video description. Thank you very much.